Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 6, 2026, just yesterday. It introduces an open-source foundation model that finally breaks the silence of generated video by producing high-quality visuals and synchronized audio simultaneously, all while running about 18 times faster than current baselines like WAN 2.2. The paper is titled LTX-2, Efficient Joint Audio-Visual Foundation Model. And as we'll see later, the results for synchronized sound and video generation are really impressive given the efficiency gains. Alright, let's break down the system design. Figure 1 lays out the architecture, which processes three modalities in parallel. On the left, we have the audio and video pipelines, where raw inputs are compressed into efficient representations called latent SPI versus AE encoders. Nestled between them is the text pipeline, which converts prompts into embeddings to guide the process. Then, everything flows into the dual-stream transformer on the right. Inside that block, the vertical arrow labeled A versus cross-attention is the critical piece, because it enables the audio and video streams to talk to each other at every step, creating tight synchronization. Well, Figure 2 opens up the hood of that dual-stream backbone. On the left, in Panel A, you see the parallel tracks with a blue video stream and a yellow audio stream running side by side. They process data independently before hitting the bidirectional cross-attention layer to swap context. Panel B on the right zooms in on this exchange mechanism. It highlights the use of temporal 1D rope for alignment and cross-modality A to LN, which ensures both streams stay synchronized by conditioning on shared time steps. So, Figure 3 visualizes exactly how that cross-attention mechanism functions. The heat maps reveal where the model focuses. The left columns show video to audio attention, while the right shows audio to video. In the top row, the attention tracks the moving car to align the sound effect. In the third row, you can see the focus shift between speakers as they take turns talking, then highlight both when they say "we are in sync." Finally, the bottom row shows the attention locking onto the mouth for precise lip synchronization. Okay, while Figure 3 focused on synchronization, Figure 4 breaks down the text understanding pipeline. On the left, the process begins with a frozen Gemma 312B backbone. Crucially, the pink stack labeled multi-layer activations shows that the model extracts features from every layer, not just the last one, to capture deeper linguistic meaning. Next, the gray blocks labeled learned thinking tokens are appended to the sequence. These tokens refine the prompt before it flows into the text connector on the right, which formats the signal for the diffusion model. Alright, moving from training to inference, Figure 5 illustrates the multimodal classifier free guidance mechanism. This is essentially how they steer the generation process. The central orange dot represents the model's standard prediction using all available inputs. To refine this, they apply two independent forces. The green arrow represents text guidance, scaled by ST, which pushes the output to match the prompt. The blue arrow shows cross-modal guidance, scaled by SM, which enforces tight synchronization between sound and video. The final result, marked by the red circle, is the vector sum of these contributions, ensuring the output is both semantically correct and perfectly synced. Now, Table 1 demonstrates the practical payoff of this efficient architecture. It compares the model against WAN 2.2, a 14 billion parameter baseline that only generates video. Despite LTX-2 being larger at 19 billion parameters and handling both audio and video, the performance difference is massive. The baseline requires over 22 seconds per diffusion step. In contrast, LTX-2 completes the same step in just 1.22 seconds, offering an 18-fold speedup that significantly lowers the barrier for content creation. Wrapping up, two takeaways stand out. First, modeling audio and video jointly allows LTX-2 to solve the synchronization issues typical of sequential pipelines. Second, achieving state-of-the-art results while running 18 times faster sets a new standard for efficient, open-source, multimodal AI. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.